Welcome. Today we're talking about inverses for our sine, cosine, and tangent. We're starting a new unit here. So the first thing we have to understand is the idea of an inverse. So if we think about inverses algebraically, what it means is that we're finding the function that undoes whatever function that we're looking at. So in the case of y equals x squared, the inverse of a square would be a square root function. Right, and then one of the cool things about inverse functions is if we draw this dotted line here, that's y equals x, it's just a diagonal line. It has a slope 1 and it crosses through the origin. What an inverse graph looks like is it's reflected across this line. So this this parabola, y equals x squared, if we reflected across this line, y equals x, we'd have this function here, which is the square root of x. Now, we run across some problems when we do that when we're discussing functions. We'll talk about that in a second. But for now, just know that one of the features of an inverse function is that it reflects across the line y equals x. All right, so if this is a graph of y equals sine x, let's apply this same idea to that graph. All right, so if we draw our line, our diagonal line, y equals x here, and we flip this over it, what we have is a graph that looks like this. All right, so I did 2 cycles here. So all it does is take that and flips it across that line. All right, same for cosine. Let's do a different color here. Let's do blue. Now keep in mind, these are not super accurate graphs, but I just want you to get the idea of what it looks like if we flip this over the graph. Cosine's a little bit harder for me, but it kind of goes like this. And then the tangent, do it in green. The tangent will flip like, whoops, that's gross. It'll flip like, kind of like that. You guys get the idea. But what I do want you to know here is that, remember back to Algebra 1 and Algebra 2 when we're talking about function graphs. Right, so in order for the graph of a function, well, in order for a graph to be considered a function, it has to pass the vertical line test, which means that if we can draw a line that goes vertically through more than one point on the graph, then we no longer have a function. So let's use a completely different color here. Let's do an orange one. So this one, right, the first one, it doesn't pass the vertical line test, because there's multiple places on this graph where we can draw a vertical line that passes through more than once. So when we talk about the square root function, right, we usually leave out this bottom one. We don't talk about that. We only talk about the positives. So it's like a domain restriction where we say, oh, we're only looking at it from this part to this part, or a range restriction where we say, oh, we're only looking at the top half of the graph, not the bottom. So if you notice that the inverse sine function, right, the one in purple, and the negative one just means inverse, right? This does not pass the vertical line test. Neither does the cosine one. The tangent one does, though, so we don't have to have a domain restriction. So this one is non-restricted. All right, but for cosine and sine, they do have a domain restriction. So the domain restriction from cosine starts there and goes to there, so that if you notice between those 2 points, there wouldn't be an overlap, and therefore we would have, it would pass the vertical line test. Same for our sine. They restrict the domain between these 2 points. All right, so let's kind of talk about how this all plays out. So when it's asking you to find the inverse for a trig function, right? Sine inverse, cosine inverse, tangent inverse, etc. It's asking us what angle. So what we're trying to find is the angle for the current value that they're giving you. So just keep that in mind. It's easy to just forget about what something is really asking us to do in math, and that's one of the dangers, because you start doing all these calculations, we're not really sure of what we're trying to find. We come out with an answer we think is okay, but we're finding something that other than what we set out to find. All right, so like we said, for our restrictions, the sine inverse, tangent inverse, cotangent inverse, and cosecant inverse, the restriction for these is all between negative pi over 2 and pi over 2. So let me kind of draw this. So we said that our sine, right, we restricted it. If we go back here, we see that it's between these 2 points. So if we just draw the function for sine within those 2 points, it kind of looks like this. So what they're saying is the maximum is at pi over 2, the minimum, well, the minimum would be like over here, would be negative pi over 2. So it's restricting it in between those 2 points. And one of the reasons why is because we need to restrict it in order for us to find our inverse. Otherwise, we'd have a non-function. We'd be finding that same value over and over again. So it's just saying when we're looking at sine inverse, also tangent inverse, cotangent inverse, and cosecant inverse, we're going to keep it simple. Our answer is going to come from between negative pi over 2 and pi over 2. Which also means that if we're talking about in terms of the unit circle, when we're looking for these specific angles, these numbers, pi over 2 is over here, and negative pi over 2 is over here. So we're looking in only quadrants 1 and quadrant 4 for our angles. Now the problem with cosine and secant, they follow different rules only because, and it's noted down here, cosine and secant is positive in quadrants 1 and quadrants 4. So if we have a negative value that we're looking for, we can't look in quadrant 1 and quadrant 4 like we did at the rest, because they're both positive in the quadrant 1 and quadrant 4. So for this one, first, cosine and secant, we're going to be looking for those in quadrant 1 and quadrant 2, because cosine is negative and so is secant in quadrant 2. So just to recap, so if we're looking at cosine and secant, we're looking for the angles in quadrant 1 and quadrant 2. Everything else we're going to be looking for in quadrant 1 and quadrant 4. So this whole page is just kind of trying to explain that idea. Alright, so let's kind of go ahead. I know it's confusing, there's a lot of stuff going on here, but once you get into practicing it and then figuring it out, then it's not so bad. Alright, so for the first example, they're asking us to find exact value. Notice that exact value is underlined. Anytime it's asking us to find exact value, that's a pretty big clue that we're going to get this directly from the unit circle. Alright, so for these ones, right, rather than looking at the angle, these are all inverse functions. We're going to look at the coordinates. So we're going to try to find where sine inverse of 0 is. Remember, for sine, we're working in quadrant 1 and quadrant 4. We're just going to get really used to knowing that it's quadrant 1 and quadrant 4 unless we can't find it in there. In that case, we're going to work in quadrant 1 and quadrant 2. Alright, so if we're looking at the sine inverse of 0, remember sine is the y. So sine is the y. So we're looking for in these two quadrants here, where is the y equals 0? And then, oh, okay, we're finding that at the starting position. At this point, it's going to be Oh, sorry, I messed that up. It's not going to be at the starting position. I'll take that back. Oh, no, it is. I'm totally messing myself up. All right, so it's going to be 1, 0. Notice our y is 0 here. And then the angle that it's at, we can write it either in degrees or radians. It doesn't matter. So 0 degrees. You could also say just 0, because that means 0 radians. If we don't have a degree, we assume it to be in radians. Okay, same idea. Sine inverse of -1/2. So we're looking on our unit circle again in quadrant 1 and quadrant 2. Well, at 30 degrees, it's +1/2, but notice we have this negative sign, so it's not going to be in quadrant 1, it's going to be in quadrant 4. And we see that sine inverse -1/2 is going to be at 330 degrees. It's easier for us to write it at the number we are given, but technically what we're going to do is we're going to go work backwards. So since we started at starting position and we went reverse, we're going to say that's at -30 degrees. And then also for our radians, we notice that that's going to be at 11 pi over 6. But we want our angle to be between -pi over 2 and +pi over 2. So what we're going to do is, because we move backwards again, we're going to say we move backwards -pi over 6. Okay, so it's not technically wrong if you put 330 because it's on the same position on the unit circle, and it's not wrong if we put 11 pi over 6 there because that's also a number on the unit circle. But because we said that our answer, our theta's got to be between -pi over 2 and +pi over 2, and if we think about it in terms of degrees, it's between -90 and +90. Our answer should technically be a number that's between those two numbers. That's why we said -30 degrees is between -90 and +90, and -pi over 6 is a number between -pi over 2 and pi over 2. So I would like you to try to get these in the correct form eventually. So try to do them the best you can, but the big idea here is to find the angle in there and then write the angle in. All right, so same, let's do cosine inverse -pi over 2 over 2. So notice again, our cosine is going to be our x, right? Cosine, we're looking at the x values from our points. So cosine inverse of a negative square root of 2 over 2 is one of those that we're going to be looking in quadrant 2 for, because our cosine is going to be positive in quadrant 1 and quadrant 4. So that should remind us, hey, wait a minute, those are both positive. I should probably be looking in quadrant 2. So if we notice in here, we find that we have our cosine being negative square root of 2 over 2 at, I don't think I left enough room over here, 3 pi over 4. If you wanted to do it in degrees, it would be 135 degrees. The most acceptable form for these ones, if you want to be technical about it, would be to give your answer in radians at this point. We should start feeling less and less like we should be working in degrees, because trig, for the most part, we kind of wean ourselves off of the whole degree thing and we start working in radians exclusively by the end. So just, if you can, try to do things in radians, but if it helps you to understand in degrees, then you can also think in terms of degrees. All right, and then I threw in these tangent ones in here because tangent's a little tricky, right? Because the tangent is the y over the x. Right, so we have to think about both of those things when we're talking about our tangent. So if we're looking at tangent inverse of negative square root of 3, anytime I see square root of 3, I know that because we're combining the x and the y, that we're going to have some case where it's square root of 3 over 2 over 1/2. So in quadrant 4, our y would be our negative, and then our x would be our positive because it's to the positive side of the x-axis. So we're looking for where our y is square root of 3 over 2, and our x is 1/2 in quadrant 4 for our tangent. And we would find that it would be at negative pi over 3. Or if you're just looking at it on the unit circle, it would be 5 pi over 3 if we're looking at just the angle that's listed on the unit circle. Okay? And then for tangent inverse of 1, anytime we see a tangent 1, we know that the x and the y are the same. And the only time the x and y are the same is when we have radical 2 over 2. So we know that this is going to be at pi over 4 if we look at it from our unit circle. All right, so you can see why it's very important to understand the unit circle. If you can memorize the unit circle, that's even better. Yeah, that's why we spend so much time on it, because you're going to see these numbers pop up over and over again, and the more comfortable you're with them from the start, the better off you're going to be down the road. All right, so the last part is just working with the calculator. So again, we kind of mentioned this earlier, but we're gonna assume that we're working in radians anytime we're looking at our trig functions and doing our trig from now on, unless it specifies otherwise. So these are all in radians. So make sure that when you're calculating in radian mode. Kind of showed you how to do that a little bit earlier. We can go over it again. So if you guys like to use the Google calculator, which I do like to use, right? So make sure that we have it on radians and not degrees. It's kind of weird because I think that it would say on the thing if we're calculating in radians or degrees. Anyways, let's go ahead and calculate these. So we're looking at sine inverse 1/3. So this is what you're gonna have to do. Is there a shift? Okay, we're gonna press inverse, which you notice will pop up all the inverse trig functions. So we're doing sine inverse, which is gonna say arcsine because some people say sine inverse as arcsine. And then we're just going to put 1 divided by 3, hit equals, and that's obviously not in radians, that's in degrees. All right, so let's go back to radians and then see if it works. Okay, so we get 0.3398. It says to round to the nearest thousand, so it's going to be 0.3398 is going to round to 0.340. Okay, let's do the next one, tangent inverse -4. Okay, so make sure radians highlighted again, right? That way we know we're working in radians. So we're going to do inverse again, tangent inverse of -4. Equal, and we get -1.3258. So we're going to round the 5 up, -1.326, -1.326. Notice we drew the squiggly equal sign, meaning that it's approximately because we rounded. Okay, and then let's do the last one, cosine inverse of 3. And notice we get an error here. Which is not wrong. So let's explain this. So it's asking us for our cosine, what this is asking us, right? So for cosine, at what angle is cosine equal to 3? Now remember back to when we're doing the graphs of cosine that our range was restricted, right? So we said that the highest, that the maximum that we could get to was +1 and the minimum was -1, right? For our base cosine graph. So what it's saying is that there's no way we can get a cosine that's equal to 3. That's bigger than our max is. So there's no angle that will give us a cosine equal to 3. And that's why we end up with an error. So let's make a note here. There's no angle that makes a cosine equal to 3. Another way to think about it is if we look at the values on our unit circle for our x's, right? X can go from anywhere between -1 to +1. You're never going to find a number bigger than that. Therefore, we can't get to 3, and there's not an angle that's going to give us an angle of 3, so there's no way we can answer this. All right, so same would be for any signs that are bigger than 1 or less than 1, right? Those will give us an error as well because there's no angles that would give us a sign greater than 1 or less than -1. All right, so that's kind of a lot of information we did today, but the work is not too bad. All right, so yeah, get started. Make sure you have your notes taken down well. Make sure you have any side notes on there for any questions that you have or any like little comments that you need to make to yourself to help you remember these ideas. So just a couple things to recap, that for our inverses, right, we are looking at most of them being between -π/2 and +π/2. The only exceptions are going to be the cosine inverse and secant inverse. We're looking for those angles between 0 and pi. And when we find our exact value, we're taking that directly from our unit circle. We're looking in those two quadrants, right? And then we're trying to find, all right, if we're looking at the sine, we're looking for the y value. We're finding that angle. If we're looking for the cosine, we're looking for the x value. We're finding that angle. And if we're finding the tangent inverse, then we're looking at the y divided by the x, which is a little bit more tricky, but the more you do it, the easier you get, easier it becomes. And yeah, we're trying to write our answers in radians, and we're trying to keep them in the correct range of values, right? So for sines and cosines, sines, tangents, we're looking in quadrants 1 and 4 between -π/2 and +π/2. And for our cosines, we're looking for it in quadrant 1 and 2, which means we're looking between 0 and pi. And we're trying to put our answers in the correct form. And then lastly, we just need to make sure, 1, we're calculating in radians, 2, that we're hitting the inverse button to get to our sines, tangents, and cosines inverse, or arcsine, arctangent, arc cosine. We're plugging those numbers in and we're rounding. And the only time we're going to get an error is if we're looking at sines or cosines that are bigger than 1 or less than -1. All right. If you have any questions or need some help, please come into class. I'm always there to help you. Don't be afraid. I'll definitely help you with anything you have, and hopefully it will be good. All right. See you next time.